This is 6, 7. Number 5. So y equals, what do I do here? Sammy. It's t to the third, right? Because I raise its power by 1. Divide by the power I get. Right? That's just t to the third. Good? Anybody want to struggle with 6?
Sure.
What do you got for 6?
I got pi theta.
Pi theta. So it goes dr d theta. They give me pi. Pi is just a number, right? So there's nothing sitting back here. Since there's nothing sitting back there, I'm raising its power by 1, which makes it to the first power, right? So I go pi theta. If I want to put a little 1 up here to remember. Divide by the power I get, which is 1. That just gives me pi theta. Because it says dr d theta. So that's normally what I take the derivative with respect to, right? Whatever that thing was on the bottom. Right? That's what we did here. This is a t, so I took the integral with respect to t.
So there's no theta.
So there's no variable. This is a number. If this was just a 3, it'd probably bother you less. Because then it'd just be 3 theta, right? Because I'm increasing this variable by 1. Right? But we have to remember is that variables can now appear out of thin air, right?
Well, this is like an X. So like,
Right.
we have it.
Make sense? That was designed to prey on all your fears. Right.
Wait, what does rewrite mean?
Rewrite means write in a way that so it makes your math easier. Everybody done with that first part? What's the answer to Hannah? What's the answer to number 8? Negative 1 over x squared. Yeah. I think that's right. Let me go fast.
Wait, can you do the chain?
Y dx equals 2x to the negative 3. So I raise it by a power of 1, divided by the power I get. I got x squared. Is that what you said? Okay. So this would be negative 1 over x squared.
Can you do like the
Aha! Now you're starting to think why this suddenly gets harder. Product rule backwards. Quotient rule backwards. Chain rule backwards.
what?
Yeah, that's where we have to go. And that's going to be uncomfortable.
Now, how do you do number 11?
Let's do number 11.
Flip it up.
11, integral of 1 over x root x dx. We know how to do that one, right? Because it's 1 over x to the 1 times x to the 1/2, which is 1 over x to the 3/2 integral dx, which is the integral of x to the negative 3/2 dx.
So you just added them.
Yes,
For number 7,
7
it would be like x to the 5/2 over 3/2, right?
over 2/5.
2/5.
Oh, sorry, over 5/2, but you'd flip that to 2/5. I should do that problem. My bad. Let's do it. 7. I'm not done with this one, though. Are you guys okay with that one? 7 was x to the 3/2 dy dx. And so y would be equal to raise its power by 1. Then you divide by the power you get. You have to do it in that order because when we do derivatives, we multiply first, then we drop its power. So to do it in opposite order, we have to wait until after we've raised its power by 1. Okay, and then I'd flip this to 2/5 x to the 5/2 because it's weird to have a fraction of a fraction. Probably critically weird to do that. That make sense? Sort of. Woo! Time to deload the roof.
For 11.
You guys got it? Feeling groovy? I got 9 more minutes. I got to figure out which way I'm going to go. Sammy, how you feeling? So? All right, let me see if I can give you the next piece of the puzzle.
You've done every problem of every single question so far.
Nice. Almost to the end of the chapter, too.
How many worksheets do I have this chapter?
10.
Is that the answer to number 11?
No, I didn't finish it yet. That was the rewrite part. So then if I were going to do the power, what would I do? X to the negative 1/2 over negative 1/2, right? So flip and multiply, I get negative 2 over square root of x, which I wouldn't leave like that. So negative 2 square root of x over x. But you guys can leave it like that because you're calculus students. They let you do gross things like that. We're going to do that. It says velocity is negative 9.8 t plus 20. Find the acceleration. To go from velocity to acceleration, you do what? You go from velocity to acceleration, you do what?
Do the derivative.
Take the derivative. So we go ahead and do that. Well, this is the continuation of the problem we already did.
Now let's.
So far, so good? And then it says, what's acceleration at 2? Well, I got no place to put a t, so that's still negative 9.8. We still good? And now for the something fake something completely different. Let's say I gave you the acceleration of negative 9.8. What would be the velocity? Oh, we know how to do that, right? We just do the derivative backwards. So the velocity with respect to time would be negative 9.8 t, would it not?
But then that's a little.
I mean, you're fine. Let's get somebody else to take a look at this. Ursula! What happened? I took the derivative, I got negative 9.8. Then I took the antiderivative, and I got negative 9.8 t. I'm supposed to be able to go forwards and backwards, but what happened? I lost the 20. Where did it go? When I take the derivative of something that doesn't have a variable on it, it drops off because it's unimportant. Where you start does not affect your derivative, how fast you're going, right? So if I start in San Diego or I start in Daytona, it doesn't matter. It doesn't change my velocity, right? My change. So we lose the starting information. When I take the antiderivative, I need to put it back. I've lost it. It needs to go back. Does that make sense? And so what we're going to do whenever we take the integral of something like this, we're going to what? Add a plus c. This is initial conditions. More on that later because we're running against the time. Okay? More on that later because we're running against the time. So you're going to stop this worksheet right there. And I'm going to give you this to do for homework. You're going to do the first, say, 6 problems. And we're going to do the first one before you get out the door. Then we'll finish the back of this next time, and then we will finish the front of this next time, and we'll be pretty close to done with this chapter. Pretty close. You're like, what could I possibly ask you? Yes, basically taking antiderivatives. So if you're in the last chapter, you should be in good shape. Here's 4. Everybody try, as soon as this thing hits your desk, try problem number 15. And I'll show you what this all put together looks like. Everybody, as soon as this hits your desk, try problem number 15. Six, 8, number 15. It's the integral of x plus 3 dx. We're putting it all together. Everything we've learned this chapter in one fell swoop right now. I'll ask Mr. Jones to walk me through it. But give me just a second. People are still writing? I've still got like 1 minute. So you're going to be ready for your answer, right?
Yeah.
All right. You got 12 more seconds. 11, 10, 9, 8, 3, 0. Good. Jones, go!
All right, so I put first x, I added the power to make it 2.
X to the 2
Then I do
over 2
that 2, yeah,
plus
plus 3x
3x
plus c.
plus c. That's the answer.
If we forgot the C on our test, that would be minus points.
Maybe minus points on your test. Absolutely.
So it's always
Plus C.
plus.
It's always plus C until I tell you otherwise. And even then, it's always plus C. It's just you're going to start skipping the step because it's not going to be meaningful. But right now, and on every problem you have, it's going to be plus C. Please do the first 6 problems, or the remaining 5 problems of the top 6 for homework. And we'll go back and we'll do those. We'll go over those, and then we'll talk about how you figure out initial conditions. And then we're pretty well done with this chapter. And again, a nice easy test. This is the one you want to get 110% on, so the rest of them, when you get hit later in the semester, you don't get hit as hard. This is the key one. This is your nice easy test if you got one.
I don't have to take it.
Nah, she said she was going to do it.
Dude, that is so discussion on everything.
Whoops.